This is video 22 for College Algebra. Today we're going to be talking about two different conic sections, ellipses and hyperbolas. So first of all, what is an ellipse? It's kind of like an oval in a non-mathematical way. But the biggest thing is we have these focus points, or they're also called a foci. So first of all, the definition of a ellipse is we've got these standard forms, okay? And we've got two different ways that we can write this. One is when our major axis is horizontal. So with that, our ellipse would be more sideways, all right? If the major axis is vertical, it's going to be an up and down oval, all right? The biggest thing here is that to know that our A value is always larger. And that's important because we switch our A and B values. Whenever we write this equation, we always start with our X value first and follow with our Y. The bottom changes with what's our A value. The foci lie on the major axis, and they are C units away from the center. To find C, we use this equation, C squared equals A squared minus B squared. And then if we have an ellipse centered at 0, 0, this is kind of our simplified equation. One thing that's new for this is eccentricity, and it is just given by the ratio of E will equal C divided by A. And what this means is the closer that value is to 0 means it's more circular. Okay, so it's going to be closer to a circle than if it's a larger number. All right, so here, would be an example where our major axis is horizontal. It's kind of a sideways oval, and this would be where it is vertical. All right, so we're gonna just go ahead and get started with some examples of this. So first of all, this one has a center at 0, 0. And we need to first find our A and B values. So our A value is always the larger. So here our A value is second, and we square root that, so it would be 5. Our B value is 4. And so from here, we can find the rest of our points, or the rest of the things that we need. So our center is at 0, 0. That's because we don't have anything added or subtracted to our X and Y values. The eccentricity, we are going to take the ratio of C divided by A. First of all, we have to find our C value. So we take C squared equals our A squared value minus our B squared value. So here we would get C squared equals 9 and C equals 3. So eccentricity is going to be C divided by A, which would be 3 divided by 5. Now our vertices, we're going to be using our A value. It's A units away from our center, and this is going to be a vertical ellipse since our A value is second. So these would be 0, 5 and 0, negative 5. And then our foci would be, we are going to use our C squared equals A squared minus B, and our foci are 3 units away, C units away from the center. So here, since our C value is 3, our foci are going to land at 0, 3 and 0, negative 3. So now we can go ahead and plot everything that we need. I know where my 0 is. I'm going to go ahead and plot my foci and my vertices. My vertices are on the major axis, and I can plot my other vertices, our other points that make this, by using my B value. So that'd be 4 units away. 1, 2, 3, and 4. All right, and so now, oops, that's one more over. There we go. So now we can go ahead and kind of connect this and try to make this as oval-like as possible. And that is our ellipse. Our next example, we're not going to work through all the way, but when we see something like this, we need to know to break that into 2 fractions. So this could be 4x squared over 36 plus y squared over 36 equals 36. And from there we can actually simplify because we need this equal to 1. And so we would simplify and we'd get x squared over 9 plus y squared over 36 equals 36. I'm sorry, equals 1. All right, our next one is we have to put this in the correct order. Right now it's not in our correct form. We're going to have to complete the square. So go ahead and start by writing this out. Put your x's together. And I like to add that blank. And then I start my y's. And I like to kind of group those together. So I've got 4y squared plus 8y plus a blank. I'm going to go ahead and put that 40 on the other side. All right, for this, again, we can't have numbers in front of our x squared, so we're going to take out a 3 for these. And for this second quadratic, we're going to take out a 4. Now the thing that we have to remember is on this side where we're adding those blanks is we're going to add 3 times something, and we're going to add 4 times something. And so we can add in our numbers. Half of -8 would be -4. -4 squared would be 16. Half of 2 is 1. 1 squared is 1. Now, I've got 3 times x minus 4 squared and plus 4 y plus 1 squared. And that's going to equal 12. Now I'm going to divide everything by 12 so that I can get this equal to 1. It has to equal 1 or it's not in a form that we can work with. All right, and so now we've got our standard form of an ellipse, and we can find all of the things we need. So our center here is going to be at 4, -1. And let's find our a and b values. Remember, our a value is always going to be the bigger of the two. Here we have a squared, so just to find a would be 2. B would be the square root of 3. So to find our eccentricity, remember E equals our c value divided by a. So let's go ahead and find our c value. 4 minus 3 equals c squared. 1 equals c squared, so 1 equals c. So my e value is 1/2. All right, to find our vertices, it's going to be 2 units away because of our a value. I know that my vertices are going to be 2 units away from my center, and this is going to be horizontal because my a value is first. So my vertices are going to be, I'm going to add 2 units to my x value, so it would be 6, -1, and then I'll subtract from there, and I'll have 2, -1. And to find my foci, those are 1 unit away, because it's that c value. So this would be 5, -1, and 3, -1. And that is all the key features of an ellipse. All right, moving on to talk about hyperbolas. We've got the standard form of an equation here. It's slightly different. Here, our a value is always going to be first, and our x and y values can flip-flop. We also have that subtraction sign. That is a key way of knowing that this is going to be a hyperbola. It's got our subtraction signs. Okay, this time to find our c value, it's a squared plus b squared equals c squared. And we've got one more added point, and this is kind of what our hyperbolas will look like. We still have those foci, but this time we also have asymptotes. To do this, we'll find k plus or minus the ratio of b and a times x minus h. Now our k value is always going to be with our y. The h value is always with our x. So up here we've got our h and our x. There's a lot of information. This printed section is going to be very useful when you're doing your homework. So let's go ahead and get started. Our first problem, let's go ahead and find our a and b values. Remember, a is always first. So here our a value would be 6, our b value would be 7. To find our c value, c squared equals a squared plus b squared. So for this, we've got 36 plus 49. And our c squared equals 85. So c is going to equal, and let's just say the square root of 85. All right, and so let's find our center. And let's just go ahead and approximate. That's about 9.2. All right, so our center here, we're going to take the opposite of our x and y values here. So this would be -2, 1. And sometimes I like to just go ahead and kind of graph everything as I am going. All right, to find our asymptotes. Here we've got y equals 1. That is my k value, plus or minus 6 over 7 times x plus 2. And that should be a minus 2. It's always that opposite of what's in our equation. Oh, no, it is plus 2. Here we've got a negative, so it is plus 2. Lots of positives and negatives in hyperbolas. All right, and now to find our vertices, we know this is going to be it's going to look more like this graph, all right, because our y is first. So our transverse axis is vertical. So I know that my hyperbola is going to open up on the top and the bottom. All right, so my vertices are going to be up and down from this point. So my vertices are -2, 7, and -2, -5, and that's from that a value. All right, and then we can go ahead and kind of plot the other points with our b value. So that's 7, all right, and so from this, I like to make a little dotted box and connect these points. There's a lot of steps when it comes to graphing a hyperbola. And this box is helping us set up the framework from drawing our hyperbola. Now the reason I didn't graph this is because I know that this graph is actually going to pass through these corners of our box. So you can save yourself some time trying to put that into slope-intercept form, and you can just graph your line like so. And now I know that my hyperbola is going to pass through my vertice. It's going to stay within these asymptotes. And here we really don't really need to draw our focus on this, so we should be fine. All right, and that's our first hyperbola. Our second one, again, here's a problem where we are going to have to complete the square. So with this, we've got 16y squared plus 64y plus a blank. And here, this is where we've got that big difference, is we've got a minus sign, x squared, and minus a 2x. I'm going to change that sign since I put the negative here. And then plus a blank. All right, so now go ahead, we've got to kind of eliminate this coefficient. So we take out a 16. And this doesn't have a coefficient, so I don't need to do anything here. On my blanks over on the other side of the equal sign, this first one needs to have 16 times something. All right, so half of 4 is 2, 2 squared is 4, half of -2 is -1, -1 squared is 1. All right, and I can Go ahead and simplify. All right, now this is a little odd, but we need to have this kind of being divided by things. I want to get rid of this 16. So the same thing as being multiplying by 16 would be if I divided by 1/16. So it looks a little goofy, but I think it'll help when we find all of our key features. And I just went ahead and put a 1 over there so we could find our A and B values. So my A value, remember it's always the first one, would be the square root of 1/16, which is 1/4. And my B value is 1, square root of 1. From here I can tell that my center is at 1, -2. To find my asymptotes, I've got y equals -2 plus or minus 1/4 over 1, which is the same as just saying 1/4. And then we've got x minus 1. So see how these two values right here come right from our center. And to find our vertices, we're just going to add and subtract that A value. So I've got 1 -7/4 and 1 -9/4. And so those are the key features of my hyperbola. This was kind of a lot, but we covered hyperbolas and ellipses.